Hello, everybody. Can you hear me? Wow, this is like the best mic quality ever. I can't hear it at all. It's great. Um, okay, so hi, I'm Andy. I'm a senior front-end developer at Shopify. I work on our merchant analytics platform. You can find me on Twitter or GitHub at Mockler, pretty much everywhere else on the internet. And before we get started, I wanted to do something a little different so we can wake up a little bit. It's been a lot of talks right after lunch. And so I thought I would just start us with a picture of a puppy. This one resonated with me because I feel like I always have to say 0 days since last accident when I put up a PR. I'm like, I broke things yesterday. Hopefully this won't again. If you don't like dogs, here's a basket of kittens that you can be happy about. If you don't like either of those, here's the void of space. There's probably something in that picture you like. And if you don't like that, here's a blank slide just to appease the rest of you. So today, my talk is titled TypeScript Ruined My Life in a Good Way. And I want to start out by talking about my relationship with TypeScript, how I got started. About 2 years ago, one of my coworkers started up this sort of side project. We were experimenting with some new things, and he was using Flow in the project, and I started helping him out, and we both really loved it. And at the same time, in another part of the organization, people were investigating how we sort of wanted to rewrite parts of our app, and they chose TypeScript, and so the rest was history. I started writing TypeScript all the time. And I love it. After using it for a few weeks, I would feel this deep guilt whenever I would start a project and not include TypeScript, because I just knew that after a few hours or a few days, I was going to regret not having types and go back and add it anyway, so I pretty much do that all the time now. So now let's talk about TypeScript and you. TypeScript is not the only answer for typing your JavaScript. In fact, typed JavaScript is not the answer for all things. There are plenty of situations and opportunities when you don't want to type your JavaScript. I mean, there's a lot of advantages to not having types. And if you do want types, whether you choose TypeScript or Flow or Reason or something else, they're all great options. So I'm going to talk about TypeScript specifically, but I'm really hoping to inspire those of you who don't use typed JavaScript to give it a try and to recognize how it could maybe fit into your current infrastructure to make you better and more productive developers. All right, so let's talk real quick about why to use types, and then we'll go into some examples. So the first one is that it encourages API-driven development. So as you're writing your types, you have to be really careful of what your interfaces are for your functions and your components and the different parts of your application. And that means that you're sort of always seeing the worst case of your API. You can't sort of hide options in an object that get pulled off later. You always have to see that full interface somewhere. And that really helps you realize when your interfaces are getting out of control. So this morning, Kent showed that component that had, like 37 props on it. A lot of times you don't notice that until it's too late because a lot of those props are optional. But if you have a type, if you have an interface, you're going to notice when that gets to 10 or 11 props, and you can already realize that it's getting pretty out of control. And it's sort of like a red flag for those sorts of things. The second one is that it's all self-documenting. So I'm sure we've all written documentation or put in comments, and then 3 months later we realize that we never updated those comments or that documentation, and it is totally wrong and misleading. The nice thing about adding types to your code and annotations is that the compiler is going to force those annotations to be correct. So if you somehow get them out of sync and you haven't updated the definitions, then the compiler is going to complain about it. And then the last thing is that it lets you let the computer keep track of the context. So if you're like a one-person team or a two-person team, maybe you can remember all of the things that you've written. You can remember all the places where a function is called. But as you get to a 5-person or a 10-person or 20 or bigger, you can't keep all of that context in your head. And this lets you kind of offload a lot of that onto the computer. All right, so I'm trying some new demos this time. I gave this talk about a month ago, and this was the only YouTube comment. He put so many dots at the end of this comment. So I'm going to try to do some slightly less basic ones. If what you want is an overview of how to write TypeScript syntax, you can check out, you can search for this title and on YouTube, and there's a video of it. But we're going to do some more applied things. So the first one is a crash course. So this is a JavaScript file. We have this function called format conference, takes in 2 strings, and then it just puts the location in parentheses. Pretty simple. And to make that a TypeScript function, you actually don't have to do anything. This is valid TypeScript. It just isn't useful because you don't have any type information. So all we have to do is annotate our types. And really where you're going to see those types is like at the boundaries. So here, all we did is change the function signature so that the parameters are typed as strings. And you can see if I change this to a number, it's going to give me a little hint here. If you don't use VS Code, the compiler still gives you these same hints. But it's telling me that that's not a string and that I have to change it. And so if I change it back, it's happy. So you can see that this was like very little work to go from no types to some types. But you're probably thinking, like, this is super contrived. I don't know why you would even put in that much effort. So let's look at a longer function. So I wrote this really bad function earlier today, actually, called format currency. It takes in an amount and then an options object. And I, a bunch of times, have been looking through code trying to figure out what I can do with a function, and there's this magical options object, and it sort of just gets lost. And you have to comb through hundreds of lines of code to know what the options are. And so you can see here we have like include sense that does something, condense thousands, and it keeps going down. And it's not only hard to know what options are available, it's really hard to know which ones are required. So like when I omit one of these, is the function going to break, or is it optional and it'll handle it, or what's going to happen? And so to convert this to TypeScript, I added this interface, which is basically like just typing an object. And I called it options. And then I put some type annotations here in the function signature. And then the rest of it works exactly how it did before. So I didn't have to change anything else inside of there because TypeScript is really good at inferring the types from if you give it a little bit of help at the beginning. And you can see that the question marks here mean that those are optional parameters, so I don't have to pass those. It'll require me to pass a currency code. If I try to give it an empty object or if I omit that one, then it's going to tell me that I need to update that. All right, so let's talk about React. So here we have a simple React component written in JavaScript. It is nothing fancy or good, but we just render this image, we put some styles on it, and we have a URI prop that is passed into the image. And that's all fine and good, and let's say a few months later, we need to add a caption because this is not very accessible, and so we want to add a new prop that is a caption prop. And that's fine, but now what do we do if we want to require that there's always a caption prop on this? So we could throw an error if caption isn't put in there, or there's a few other things. We can do a global search in our project to find all the instances where it's been used, but that can be a little tricky. So let's look at how TypeScript can help us with that. Here you can see that it's basically the same at the start before we have that caption. We have a props interface, so that's just typing this object. And then it knows that props has a URI property. We add our caption, and we make it optional at first. So people can use this or not if they want to, depending. And then finally, we take away the question mark, and it'll be required. So I have like a small example here. So this is like a blog site that we have. In the top left, this is that article image component we were just working on. Caption is optional. And then we have these 3 other articles that are consuming article image. And if I just take away this question mark and make it required, you'll see that in all of these files, I'm now getting an error that tells me that caption is missing in that type. So this is great because the compiler is going to know when you're trying to use which things, and it's going to be able to catch it. It also won't let you build this code. There's certain ways around that, but it makes it more difficult to build this code with errors like that. So it really gives you a lot more peace of mind about being able to know that your APIs are being updated and that things are consistent with how you want them to be. All right. So hopefully I appeased that YouTube commenter with that slightly less simple. Okay, so let's talk about writing effective TypeScript. So the first disclaimer is that at the end of the day, all of these types are lies. They're just written by humans. You're consuming some packages or maybe some annotations inside a package, especially when you start typing like your data interfaces. So like if you're connecting to a REST API and you have interfaces for REST, you're the one who wrote those. And so you can't get too complacent. You still have to keep track of when things are happening, but it does certainly help a lot. The second thing I would say is treat your types like normal JavaScript. So a lot of people think like, oh, TypeScript, it's like so much different, or like writing types, since these get compiled out, we can do all these different things. But you already have best practices for your JavaScript code, and you should just use those same exact best practices for your TypeScript, for your types. I would say put effort into your types and avoid any whenever possible. So there's a compiler option that says you're not allowed to have any, which is really great. And it is a lot of work up front to put in types. It definitely slows you down a little bit, but it pays huge dividends down the road. So I would really recommend like taking the time to do it. And then the final thing, these are my opinions. I would say like steer clear of type inheritance, avoid clever types. All of this goes back to treating it like normal JavaScript. So the same rules that you have for writing good code, use those to write good types. So I hope that I've inspired all of you to give TypeScript a shot or some other type system. Thanks for listening. You can ask me questions on Twitter or come find me. And yeah, thanks a lot.